I'm Mike Peace. I'm not an actor, but I'm an experienced wood turner. Today we're going to show you a number of different techniques that you can put in your arsenal on how to hold wood. We're going to cover a variety of commercial and shop-made accessories to hold wood, because if you can't hold it, you can't turn it. There is no best way to hold a piece on a lathe. It's really a personal preference based on your considerations of convenience, speed, cost, the equipment you have on hand, and safety. As we talk about safety, I want to highlight just a couple of things briefly. Number one, protect your eyes. I almost always use a face shield, unless I'm turning something small like pens, where I might wear safety glasses. Other important considerations besides just protecting your face are: don't stand in the line of fire, especially when you turn the lathe on. And lastly, always turn at an appropriate speed. If you turn too fast with a large unbalanced piece of wood, you're just asking for trouble. If you feel uncomfortable with any technique that I'm demonstrating today, just don't do it. Let's start by talking about turning between centers. I'm going to talk about drive centers. I'm going to talk about locating and marking centers. We're going to talk about seating centers, and we're going to talk about live centers. When we talk about centers, we're a drive center. We're talking about something that looks like this. This is a 4-spur drive center that comes with a jet mini lathe. It mounts on the lathe using something we call a Morse taper. There's 3 types of common Morse tapers on lathes. There's the number 1, which is usually for older lathes like Craftsman, maybe Shopsmith. The number 2 is the most common. You'll see that on virtually everything from mid-size mini lathes such as the Jet and the Delta and the Recon to the Powermatic, the Jet 1642, and the larger lathes. 4-spur drives are generally used for turning spindle work such as balusters. I find them not very useful or friendly, and unless that's all you're going to do. This one with the Powermatics, virtually the same, just a little bit larger. You also have 2-spur drives, again primarily used for baluster or spindle work. I don't find them too useful, because I'm going to show you a drive that I like in preference to that. And that one I like in preference to that is what we call a steb center. It has a row of teeth, and it has a spring-loaded tip, and it's very effective. It provides some of the same safety features as what we call a safety center, and that's also spring-loaded, but it doesn't have the teeth. The advantage of a safety center is that when you're using it, if you get a bad catch, for example, if you haven't quite mastered the skew, the wood will actually spin on the safety center if you get a bad catch, and instead of destroying the work you're working on, it may only just damage it a little bit, and you can recover. But again, the steb center provides most of those same features. Let me demonstrate some of the features of the steb center that make it very effective. You go ahead and mount it in the Morse taper so it seats. Mount a simple spindle. Here's the aspect of a steb center. If you're doing production work, you can actually slow it down, and as you take pressure off of it, the lathe is still going, but the steb center is released, and you can actually check your work. So that's one of the advantages in production work. Okay, let's do a quick demonstration on some of the problems of why I don't like the two-spur drive center, and that has to do with the difficulty if you're doing things such as bowls as opposed to spindle work. We're going to take this bowl blank, which is somewhat dry, align the spurs with the grain, and try to seat it. And we have. And you can see we've aligned the spurs with the grain, but you can see how difficult it is to hammer it in, and part of that reason has to do with this is not spring-loaded like the step center we showed you. Another drive center I'd like to show you is what we call I call it Al Sturt bowl driver, because Al Sturt designed this, and this is for using initially turning a bowl between centers using this driver, because it gives you the opportunity to actually orient the grain. You have to imagine a larger blank and you do have to drill a hole for this. It allows you a better opportunity to align the grain when you're initially turning it, and it does work better than some of these others for a very large bowl blank. Also want to talk briefly, when we talk about Morse tapers, we have to keep them clean. That means if you're using a chuck, you may have a tendency to get some dust in there. Before you seat a Morse taper, you want to clean it periodically. Blow it out with compressed air. Use a green weenie, which I don't have, it's a piece of plastic with spiral cuts on it. But you want to keep it clean because there can be debris in there, and debris can cause you some serious problems and damage to your spindle if the debris gets between the spindle and the Morse taper. So keep it clean. The other trick I wanted to show you, we talked about how some Morse tapers are shorter than others, even in the same size, such as a number 2. There is a technique, if you happen to use a short one, for example, on a mini lathe, probably using this drive center as a better example, you can release it. Most lathes have what they call self-ejection on the quill. You turn it and it self-ejects. You don't have to use a knockout bar. But if you try to use a short one, this is one that came with the Jet Mini, it will seat fine, it will work fine. But you go to try to eject it, and it'll stall and it won't self-eject. I want to show you just a quick technique, because that's not necessarily a problem. If you use something, for example, like a parting tool, you'll just catch the edge here and get it between the tailstock body, and it doesn't take but just a little bit to release it. So that's kind of a handy technique. We've talked about drive centers. Now let's talk about marking a center to use a drive center. There's a number of different devices to mark centers. Here's some of them shown here on the table. The easiest one, and one of the oldest ones, is just if you're doing square stock such as this, is simply brace your fingers and draw a small square, and that allows you to easily visualize where the center is. Other tools that will accomplish the same thing are these plastic center finders. Here's this one. Here's a multi-purpose one, which includes that from Technitool. And you just simply go around. If you have mill stock where it's perfectly square, you can just do this twice. My stock is normally bowl scraps, green wood. They're not perfectly milled. I don't run them through the joiner, so you need to go through all 4 sides. And then that allows you to have this very small square in the middle to mark it with. Some people use an awl. That's effective at marking the center because you want to put a small indentation there for your drive center. I prefer to use a spring-loaded punch, and that works very well by just doing that. The other technique is, instead of going to this trouble, if you just train yourself by aligning your eyesight, imagine an imaginary line there, line it up here, imagine the line there, and just practice locating in the center. If you practice, pretty soon you'll get it almost dead center every time with very little effort. When you start talking about bowl stock or larger stock, such as this, a bowl blank, there's other ways of marking it. This is one that would be purchased at the store. It's fairly round. You could simply make you a center like this. There's instructions on the internet. This is on the Technitool website. And it works very similar to the plastic ones, but just for larger material to mark the center. Wax is not allowing this to show up real well, but where the lines intersect, that's your center. Another technique, and this works for large and ugly bowl blanks that might have square facets or sides on it. I simply made a center locator out of a piece of plexiglass, and actually you mount this on the lathe with tailstock support and turn it, and you can draw score these lines with a skew. But you can just visualize by where the circles best match the outside, and you can identify the center. And then again, using the spring punch, the spring-loaded punch, you can mark your indentation. And that's handy whether you're turning it between centers or whether you're going to take it over to a drill press and possibly drill a hole in it. You'll see we've drilled a hole in this bowl blank, about a 1 1/8 inch hole. It matches this large steb center. This model is from Penn State. There's also more expensive models by Sorby. If you're turning, for example, a natural edge bowl and you're going to turn it between centers, it pays to cut through the bark with a drill and seat the drive What this allows is you've got some ability to shift the bowl blank on the lathe, but in addition you don't have to worry about it. If you get a catch, it's springing loose or getting away because it's trapped by that circle, or by that hole we've drilled. This is another device for marking centers. It works very well in a production environment if you're doing something like balusters. You simply seat it, smack it. If it's perfectly milled, 2 turns will do it. If it's not perfectly milled, do it again. And you can see, again, we've got these lines because it has a knife edge here that actually scores it and marks it. So those are your different techniques for marking the center. Now let's talk about some of the techniques for driving the center in. We've started that with the bowl blank. The only other point I'd want to make when you're mounting a center, whatever you do, use some type of mallet, a rubber mallet, plastic mallet, dead blow mallet. Do not use a steel-faced hammer when you're hitting these Morse tapers. avoid mounting the wood and pounding on it on the lathe. That doesn't help your spindles. But hitting a Morse taper with a hammer can damage your Morse taper. Let's talk about live centers now. Here's an example of several different live centers. This is the one that I said comes with a Jet Mini. It has a point that can be removed, and it has this edge that prevents it from actually splitting the wood. The ones that come with a small mini lathes or mid-size lathes are generally going to look very similar to this. This has one bearing. The larger lathes, the more expensive lathes, are going to come with something probably a little nicer, something similar to this one with the Powermatic. There's also one sold by One Way that's very, very similar to this. The difference is it has two bearings. In addition, you'll notice it has this threaded feature about it, and that's handy because you can mount a 60-degree cone that comes with it. It also comes with this little device to anchor this, so you can mount that 60-degree cone. This tip is also removable. You're supposed to be able to use this tool. I found if you use this tool, I've straightened it out, you'll just bend it all up. It's just not strong enough if you wind up with some debris down in here or rust, or you haven't removed it. So what I did was simply make a larger punch-out bar. This is 3/16 inch music wire. You could use something up to about 1/4 of an inch. But if you just take it, give it a little smack, it'll eject that tip. Why do you want to eject it? There may be times when some work you're holding, you just want this ring to be the only thing. You don't want that indentation that's caused by the tip. One of the features of this threaded ring, this happens to be 3/4 inch by 10, which is a standard bolt size, is you can make adapters. In this case, you could make a 60-degree cone adapter. I made it look like this one, which doesn't provide a whole lot of usefulness, but it can in some circumstances where you're turning right up against the edge of this. You don't want to damage or cut into the aluminum, but if it's wood, you don't have to worry about it. You can get your gouge right into the wood, and because it's an expendable accessory. And you can make all types of different accessories that you can customize for your product that actually thread right on that adapter, similar to that. And we'll talk about threading adapters in just a moment. Here's an example of a commercial 60-degree cone. These are very inexpensive, so if you wound up with a Jet Mini and you don't want to pay $100 for a nice fancy one like this, but you want a 60-degree cone, you can get these for $15 or $20 from most any wood turning supplier. Of course, made in China, only has one bearing, but it's not a bad tool. The 60-degree cone, one of the advantages of the 60-degree cone is if you're turning something that has a large hole in it, this could be a tool handle, could be a twig pot, any number of things, it will actually hold your work in that hole. So this is a nice feature for some turning. It's not something you would normally just routinely use in place of your regular live center, because it has a tendency to act like a wedge, and it either potentially split the wood, or it may follow a particular hard grain that as you crank it down, you may have a tendency for it to come off center and introduce some wobble or distortion or lack of concentricity. So, we've talked about turning between centers. We've talked about the different types of drive centers. We talked about marking the center and locating the center. We talked about mounting the drive center, and we looked at the various live centers. We've talked about turning between centers. Now we're going to talk about securing the work on just one end of the lathe. We're going to start with talking about faceplates, which is a primary way of doing that. Here are a couple of examples of faceplates. This is one, a smaller one that comes with the Jet Mini. And here's the kind of screw I would recommend. For the Jet Mini, you'd use about a number 10. I like to use machine screws or metal screws that are very strong. They don't have to protrude very far. This is a larger faceplate that comes with the Powermatic. It uses a number 12 screw. If you have some other types of faceplates, you may notice that you'll have a beveled edge. If so, you'd want to use a screw that has a beveled shoulder. But if it's flat like this, then you'd want a screw with a flat shoulder. It pays to pre-drill the holes. If you don't, you have a tendency to sometimes mushroom the fibers around the edge, and that has a tendency to introduce vibration. Don't over-tighten the screws, because you will have a tendency to pull the fibers and tear them. And if you pull and tear the fibers, it's not going to hold. I mentioned machine screws. The one thing you don't want to use are drywall screws. They're too small. But mostly they're too brittle. So don't use drywall screws. If you're using a small blank, you may only need to use 2 or 3 screws. With a Powermatic, you can use, I've turned blocks upwards of 50 pounds with this, and it will hold it just fine. I'd use all 6 of these screw holes, but if I'm using a smaller bowl blank, I would only use probably 3 or 4. You can also make your own faceplates. Here's an example of a faceplate or a glue block made out of wood. You can tap these threads yourself using this device, thread tap. This one's a Beal tap. They come in a couple of different sizes. This is a 1 1/4 for a Jet 1642 Powermatic type of size. For a 1 1/4 hole that you're going to tap, the directions will tell you, but you're going to use a Forstner bit that's 1/8 of an inch smaller to cut the threads. I simply made this tap handle to be able to turn it. Let's go to the lathe and I'll show you exactly how this process works. So the way you would actually tap this is you're going to need a larger set of jaws, but you're going to fix your block of wood on this set of jaws. You're going to start this in the hole, bring up your tailstock support, and there's a 60-degree divot, so your 60-degree cone center works very well. And then you're just going to keep the tension on, turn it back off until you cut all the way through. And when you finish, you're going to have to mount this and cut this little recess right here. Let me show you. Most spindles are going to have a shoulder right here, and that shoulder has got to fit inside here because this face has to mate against the surface right here. So by having that recessed shoulder, it will mount. You can take this faceplate, if you will. You can either mount it to your work by drilling holes and using it like a regular faceplate, or you can glue it to your work depending on what it is you're doing. In terms of mounting your work, we talked about using screws. Another way of effectively mounting your work is using a special double-sided turner's tape. It's a very, very strong tape. It's a cloth tape. You can actually put a couple of strips on your faceplate and you could easily turn a blank such as this without any problem. The key is clamping it for about 10 minutes to get some pressure on it. Turner's tape also, and you can get this at any wood turner supply shop, it also works very well for small items. Say you want to turn a small medallion to chatter, for example, like this ebony for a box insert. You just clamp it to your block with that tape, secure it for a few moments, and then you can chatter it and then pry it off very carefully with a chisel or a narrow parting tool until it pops off. When we talked about live centers on the Powermatic and the one-way live center that's threaded 3/4, I showed you one or two examples of a threaded accessory block that you can turn and fit for whatever use you want. You can actually do that by making your own tap. Similar to the Beal tap, you just get a bolt. In this case, these are available from any of the big box stores or hardware store because it's a standard size, 3/4 inch by 10 threads per inch. You simply cut about 3 grooves down the side of that bolt. Use a combination of a Dremel, angle grinder, file. They don't have to be nearly as pronounced as the one on the Beal tap. That'd be nice, but it takes a lot more grinding, but they don't have to be that deep to work. You taper it just a little bit, and you can thread those blocks of wood very easily. I wind up doing this not on a lathe, but holding this in a vise, and I found out to turn this block I had to make my own tap handle. I just kind of knocked something together of that nature. So once you take that bolt, you're ready to tap this thing, and you get the block tapped, and you got this square block. You're going to wind up just threading it on here. Here's one that hasn't been fully rounded. You're going to thread it on here, and you're actually going to use your live center as a drive center. And you do that by simply taking a piece of wire and putting it in here, and that will keep this from turning, and then put a piece of tape around it. And then you can mount that on your lathe, bring up your tailstock support, and then you can turn this round or shape the outside of it for your particular purpose. When you're using any of these blocks, it hurts. It doesn't hurt. It actually helps if you use a little piece of paraffin to put in these threads, and it makes these glue blocks turn on your spin onto your either your lathe spindle adapter or your live center easily. Another example of a glue block. This is one that's mounted on 3/4 inch wood, and it shows a good example of how you would use a glue block to as waste material where your piece of wood is not as large as you'd like it to be. You can so you've got some that you can actually turn a tenon on, or you could use one that like I've illustrated as a faceplate, and actually to glue it on and use it for this type of work. Glue blocks are also useful for small pieces of exotic wood. In this case, the glue block is made on, so it'll be chucked on a lathe. I used end grain to end grain, which is not the ideal way to glue up a glue block, but for small things it works. But for larger work, you'd be better off having your glue block similar to the one we tapped. Have it with the grain crossways instead of an end of a piece of spindle scrap. Here's another example of use of a glue block. You've got a small piece of exotic wood, or it could be something that's an odd size, such as a tagawa nut or a piece of bone or antler that you want to turn. You would mount that on a glue block. In this case, you drill a hole and use glue to mount it in that hole to turn that odd piece of wood. Let's talk about another way to secure wood without tailstock support, and that's through the use of a screw chuck. You can make your own screw chucks by simply mounting a piece of scrap wood, in this case plywood, onto a faceplate. Drill the hole while it's on the lathe so you can get it center, and mount it with a lag bolt. That's all this is a lag bolt. If you're going to use it a lot, it's not a one-time thing, you might want to recess this just a little bit on the back side and put some epoxy to give it a little, make it a little more secure, depending on how you're going to use it. Here's examples of some shop-made screw chucks, nothing fancy, they're just scraps of spindle leftovers I throw in a box. Again, you turn it between centers to turn a tenon, mount it on your chuck, drill a hole, and then use it, in this case, for small items such as a drawer pull. The screw chuck is very handy for small work and production work. In this case, you make your screw chuck and you use it similar to the bushing on a mandrel as you're turning pins. You use the wood to actually size the base of the drawer pull if you're making multiple copies and you want them to look somewhat alike. Here's a similar apparatus, except I didn't turn the bottom to match the bottom of a little chess piece. And it's nothing fancy. This is just a wood screw with a square head. There's no glue. I just turned it in. And it'll generally hold small pieces very well. The key thing is use tailstock as much as practicable, and take small, light cuts with a very sharp tool. We're going to talk about woodworm screws later in this presentation as we talk about 4-jaw scroll chucks. Okay. Now let's talk about another method for securing wood without tailstock support, and that's a jam chuck. Here's an example of a piece of pine, not necessarily the best piece of wood for a jam chuck. If somebody says, what's the best piece, what kind of wood is best? Scrap wood, free wood. Generally you want a softer wood than the item that you're going to be turning. So let's move to the lathe. Let me show you how this works. Okay, now that we've got this mounted on a chuck, the item I want to point out here, if you can see this close up, the key to this is a nice square shoulder, very flat, clean, and you want a very slight bevel, perhaps 3 degrees for your work. And it's this shoulder and this bevel that holds it very secure. So this bevel is a little bit like a Morse taper. Here's an example of a box. We pop that on. I just want to show you that this will run fairly true. So the idea is you would use this primarily for finishing the very end of a project on the base. Key is light cuts, use tailstock as much as possible. It's frequently used, even when you have other alternatives, for box lids in the process of using the box. In many instances, you'll actually use the box itself for the jam chuck for the lid while you're finishing the lid. Let's move back to the table and I'll show you a couple of other examples of jam chucks. Let's look at a couple of other examples of jam chucks. Here's one where making scoops, again that 3-degree bevel, and it's just for doing the final finishing on the end. In this case, because it's extended out so far, maybe just to sand it, you might have to support it a little bit with your hand. This is a technique for using bowls using a jam chuck. We'll talk about shortly some other ways of finishing off the end of the bowl. The key is, if you're using jam chucks, sharp tools, tailstock as much as possible, and very light cuts. The other thing to keep in mind about jam chucks is it pays to have a little hole in the bottom, because if you get one of these things mounted, you leave it overnight, the wood moves, you get it a little bit too tight, and you have a hard time tapping it out, generally if you'll take a mallet or a tool handle, normally if you hit on the side, these will pop right out. But every now and then you'll get one that won't. When that happens, it's nice to already have a pre-drilled hole with a dowel that you can pop it out. Another technique I'd want to mention, if you get one of these things and it's not turned precisely, you make it a little bit loose, there's a couple of techniques. You can use some paper towel, or what the Aussies might call kitchen paper, and that may help you out of a jam. The other possibility is use what we call tongue oil. You just get a little moisture and put on there, and that'll swell those fibers, and sometimes that'll be just enough to secure it. So there's a couple more techniques when you don't have them turned exactly precisely to fit. Okay, let's continue talking about some of the different ways to mount without tailstock support, and that's using movable jaw chucks. There's several different types of movable jaw chucks. There's the more standard 4-jaw scroll chucks, and we'll talk about those shortly. There's using a Jacobs chuck. Not going to do much talking about this because this is not a real effective way to do it. You'll notice that the teeth are so sharp and it so distorts the wood, it's just not an effective technique. But it is a movable jaw chuck, but mostly used for drilling, mounting a drill bit, putting it in tailstock. Another example of a movable jaw chuck are collets. So let's talk about collets now. I'm going to move and show you how this works by mounting it on the lathe. Any of y'all used a router are familiar with how a collet looks. It looks similar to this. It has these teeth. But we're using, in this case, a drawbar to mount this. And the back of the collet is threaded. The drawbar will go inside that thread. And this drawbar is simply 1/4 inch rod. The advantage of a collet chuck is if you're doing production work on small items of a repetitive nature, the beauty of it is because of these jaws are smooth, it can clamp tight, it doesn't mar the work, you can mount it and remount it. The disadvantage of it is your tenon has to be a very precise size because you have very little room for movement here. And this is just an example. So as I turn the drawbar, haven't engaged it yet. As you draw tighten up the drawbar, it's going to clamp down. I'm having a little bit of difficulty securing it, so we're not going to worry about that. But it'll clamp down on it. You can also make collet chucks, and I'm going to show you some examples. Here's one. I got this idea from Bob Hamilton on the internet that does a lot of YouTubes. Let's say you had the challenge of doing a production run of, say, 50 birdhouse ornaments with little perches. And rather than start from scratch on your perch, you came upon the idea that you use little 1/8 inch bamboo skewers. You could mount this through this hole in this collet chuck from the rear. This can actually extend into your spindle shaft, except in this particular case I've forgotten I have a spindle adapter that doesn't have a hole on it. That's why I had the shorter version. But if you didn't have a spindle adapter with a long hole, you can extend it through here, so you can mount it. And similar to the other, it has one narrow notch. I turn a tenon, cut a little groove with a handsaw. Tighten that up. Doesn't need to be too tight. Turn off your perch, part it off, loosen it, pull it out, do the next one, pull it out, do the next one, pull it out, do the next one. So it's just a technique that may be of some use to you. Other examples of collet chucks, here's a couple of different ones for finishing off the tip of an egg, mostly for sanding. This one is out of wood with a tenon that mounts in the jaw, and you tighten it up with this clamp. It's pretty crude, it's pretty scary with this thing coming around. It's probably not the safest method of fastening one down. This one's not much better. Somebody posted this on the internet. It's made out of a couple of PVC fixtures. Inside there, you taper it just a little bit where there's a little bit of a recess that this will pop into and tighten down. But it's just an example of how a collet works, tightening down from a different mechanism. Here's an example of a collet chuck. This is Mark St. Ledger's approach to doing a small collet for a box lid. So instead of turning a jam chuck that we talked about, where it has to be a fairly precise fit, maybe one accurate to about 1/64 of an inch to get a good fit, by turning a collet chuck of this nature with a saw kerf in it, you can actually extend that range of motion down to about 1/16 of an inch. And you can put that in your four-jaw scroll chuck and tighten it down, and it'll hold this thing perfectly well. So it doesn't work, it actually works a little better than a jam chuck because it's tighter, but also you don't have to be as precise, and you can produce these things and have bunches of them around if you turn a lot of little box tops, box lids. Here's another example of a collet use similar to that. Let's say you had a one-time project and you only have your #2 standard jaws. You could turn you a temporary collet that would fit in those jaws. And this is just a spindle scrap out of my scrap bin. And it allows you to turn something smaller for a temporary use. Obviously, if you had to do this a lot, you'd probably want to get smaller jaws. But it's just an example of how you can be creative, and again, based on your factors of how important is cost or convenience to you. You may have a situation where you have a need for a one-time collet to fit something smaller. Here's just a little piece of PVC with a slot in it to reduce it just a little bit. So it's just another application. Okay, let's talk a little bit about one of the basic tools for wood turners. It's a convenience, but it's not a necessity, and that's the four-jaw scroll chuck. We've got pictured here a number of different chucks, and I want to talk a little bit about the different manufacturers and some of their different features. I'm just going to point out some of these different chucks. This chuck with his large set of jaws, this is a Vicmark VM100 made in Australia. This is a Technatool G3 chuck with a 25mm set of bowl jaws on it, and it uses this keyed geared chuck key. Supernova 2, also made by Technatool. These jaws, all the jaws are interchangeable on all the Technatool chucks with one exception. It's pretty esoteric, I won't go into. We've got a Barracuda chuck. This is the large Barracuda. Then we've got a smaller Barracuda. All of these chucks on the table are geared chucks that use a key. Some of them use something like an Allen wrench. Some of them use a geared type of chuck. We don't have an example of a chuck style that uses what they call Tommy bars. And that's two bars that you pinch together with one hand. They're found generally on older chucks or less expensive chucks. Some people find them not as convenient as one with the key. Something to keep in mind about the chuck, the general rule is larger chucks for larger work, smaller chucks for smaller work. This Vicmark is generally considered to be one of the best quality chucks. Grizzly makes a Chinese knockoff of the VM100 where the jaws are interchangeable, which I understand has very, very good reviews, and it's a little over $100 for that Grizzly chuck, whereas the Vic Mark is probably closer to $300. Generally, weight-wise, these chucks go something like, these are about 5-pound chucks. This is probably might be close to 8 pounds, and then the smaller chucks are about 3 pounds. There is a larger set of chucks, such as the Technitool Titan, which we don't have, and that is coming back on the market. They had some production issues, and it's similar in size and weight to the one-way Stronghold chuck, 8-pound, which is a very big chuck. One of the other features about the chuck I'd like to point out is, besides the Tommy bars and the size, is whether they have an open or shielded back. In this case, the Nova G3 has an open back, and you can see the gears. The Super Nova 2 has a closed back, so it's sealed. The only issue there is you have to keep them clean. Open back, blow them out with compressed air occasionally. Don't let them get too clogged, or the gears will start getting a little bit sticky. I've been using this Supernova for almost 5 years, and I've never had to take it apart to clean it. Let's talk a little bit about jaws. There's lots of different jaw types, so if someone says, well, what kind of jaws should I get? It's really a function of what type of turning do you do. But again, similar to the chucks, larger work requires larger jaws. Smaller work requires smaller jaws. Any of these chucks could be used on a mini lathe. Any of these chucks could be used on a larger lathe, such as the Powermatic we have here. But in terms of the different kinds of jaws, let me just point out some of the features in mind. When it comes to jaws, there's what you might call 3 different styles. There's the jaw that has serrations. You can pick that up. There's that grip with those serrations. It holds very well on large pieces of primarily spindle grain, like a large vase or something of a hollow form nature. It doesn't do as well sometimes when you have to rechuck it, because those serrations tend to make it a little harder to rechuck it and have it run true, but it's very strong. The other style is what we call a dovetail, and that refers to this angle that you can see here. This Technitool, this is a power grip jaw. This is suitable for very large work. Bowls, for example, maybe more than 16 inches or more than 12 inches in size, and maybe as deep as 4, 5, or 6 inches. On the inside, this Technitool, it has a lip. It's not truly a dovetail, it's a lip. So Technitool says you don't cut a dovetail when you're using this to in compression mode around a tenon. These jaws are also Technitool. Technitool again fitting the Supernova 2 or the G3. These are called their long jaws. One of the things, advantage of the long jaws, is that it gives you a little more standoff room between the chuck and the work. So it makes it a little easier to do some cutting on the back of a bowl when it's mounted, when you've got it mounted in a way that you can work on the front or the back. Again, these are called spigot jaws for the Supernova 2 or the G3. They're primarily used for hollowing type of work, where you're something is going to project out from the chuck more than 4 inches. So you normally would not use this for bowl turning. The power grip jaws have similar holding capacity, except it's also suitable for platter work or very large bowls. Then you have small bowl jaws. These can be used for small bowls. It can also just be used for small spindle type of work. These are called pin jaws. Pin jaws are useful when you have round dowels. Normally there are no serrations in pin jaws. So it's good for work involving bobbins, finials. The other function of a pin jaw is it's a quick and dirty way to mount on some work where you just drill a 1-inch hole into the work and then seat it right on here and have that in expansion mode without having to actually cut the expansion slot. You just take it to the drill press, drill a hole, and stick it in here. This is a turning ring. This is actually a faceplate where you mount it on the bowl or other object being turned with screws, and it gives a very secure hold by using the appropriate matching set of jaws that will expand in here. Then we have the cold jaws, and we'll talk more about this as a solution. Cold jaws are used for finishing the back of a bowl. I don't much care for them myself because I find that they're very fussy. Each of the 4 jaws has these 2 rubber bumpers that'll grab your bowl. You have to adjust those depending on the size of the bowl, so there's a lot of adjustment. And because of the size of these, not really a disadvantage, but just something to keep in mind, you can't turn as fast as you might on some other types of jaws or work. So we've covered the different types of chucks. We've talked a little bit about the types of jaws. Now let's talk a little bit about how we're going to use these jaws. Chucks generally are adaptable from one lathe size to another, one spindle size, with what they call an insert. This is an example of an insert. So the chuck body will be threaded. That thread might be a native 1-inch by 8 threads per inch to fit a mini lathe, or it might have a thread that doesn't fit any kind of lathe. It'll only fit the spindle adapter. This spindle adapter, for example, will convert a 1-inch thread to a 3/4 by, I believe it's 16, which fits, I think, on some of the old Craftsman or Woodsmith. The other method of adapting chucks are are spindle adapters. Here's an inexpensive spindle adapter from Penn State. Here's a more expensive one. I got this spindle adapter, so I can take this chuck right here with an 8-inch, 1-inch by 8 threads per inch, which fits my Jet Mini, and instead of changing the insert, I put the adapter on it. Now I can take it off a Jet Mini, or if I go out to a wood turning Saturday with my club where we use minis, I can take this chuck, I can put this adapter, and then I can simply mount it right on the Powermatic. And I leave this fastened on here all the time and only take it off if I do use it on a 1-inch. So let's talk about safe chuck mounting. We're going to take this Supernova 2 and I'm going to illustrate some pros and cons of or how you make a safe tenon. Okay, before we mount this chuck, let me point out one thing in the process. You'll notice here on this lathe we have this nylon washer. Some of my wood turning associates say these washers are great because it keeps the chuck from locking up. Others say it's not as machined as the back of a metal chuck, therefore because it's plastic, it's going to introduce vibration. I agree with my friends. I would say if you don't want to get in a habit of taking a chuck and then spinning it on to lock it, because it can be very difficult to remove and you can also cause some real problems by doing that. However, if you do have a tendency to do that and it is going to lock, and it does lock on you, you can prevent that by the use of one of these nylon washers. But if you do a close-up here, you can see some of the potential problems with a washer. You can see where actually some of this nylon has actually been crushed, and that's going to tend to introduce, that kind of crushing can introduce some problems. So let's talk about a tenon. One of the key features when you make a tenon is it's got to be a very nice, clean shoulder right here. Very sharply defined at a 90-degree angle for this Nova chuck. It's got a ridge. You do not have to cut a dovetail in here. This lip, which is not a true dovetail, will actually grip the wood, and Technitool says don't cut a dovetail, don't cut a groove, let this grip do its job. So we can see this one is cut fairly cleanly. I'm going to mount this. Now, what is the problem with this tenon? I want to point this out is you have this huge gap around here, and that's because the tenon is bottoming out against the bottom. A good tenon should never bottom out against the tenon. The goal is to have this no gap here. The other problem we've got here is the tenon is too large for this chuck, so we have these large gaps. When they manufacture these chucks and these jaws, this is turned out of one piece of steel. Then they'll cut it on a saw. That gap is the perfect circle, a gap of somewhere a 1/16, 1/8 of an inch. That's the optimum size for best strength and minimum marring of the piece. And let me show you an example of how that can work. We have this tiny little ingrained bowl here that's got a couple of very small grooves. Those grooves are adequate to grasp in a chuck that's got this lip. So if for some reason we had to remount this, it'll work just fine like that. We could actually mount it on the other set of grooves. So the point I'm making here is if you design this type of feature into some of your work, it gives you a solution for effectively holding the work for another part of the operation. Here's another example of that, lid on a box. So how do you finish the top of this lid? You remember we said earlier jam chucks are frequently used for box lids, a lot of times when the body of the box is mounted. But what do you do when you design a box that has a loose fit? Because you don't want somebody with arthritis to struggle with it. You want the box to intentionally be loose. There's no way it's going to jam fit on there. So when you go to finishing that, one way to do it is you design it with this small groove in here that becomes really kind of a decorative element. So now let's look at another example of some tenons on the mini lathe. Okay, let's mount this and let's look at this tenon. We saw it had a clean shoulder. It doesn't bottom out. So what do you think? Is that a good tenon? Well, the test is, can you get a piece of paper between the wood and the jaws? And if you can, you got a problem. Because this is going to introduce, when you start leveraging out here, it's going to introduce a movement. You can actually see that moving with my hand. And ideally, we'd have a slightly smaller tenon for this size jaw. So let's look at the other tenon, and again it doesn't bottom out. But we can't get a piece of paper in there because it's a nice, clean, firm grip, and that's what we're looking for on this type of on a tenon. When we deal with using these jaws, it's very easy to crank down and crank too tight. You want to make it tight. You want to go from one screw to the next and tighten down, but you don't want to crush the fibers. If you crush the fibers, you're going to weaken the hold. It's going to introduce vibration. We've talked a little bit now about tenon. Now let's talk about the other method of holding in a 4-jaw chuck, and that's the expansion mode, as shown on this large bowl right here. In this case, we're going to use a set of jaws similar to what we have on the Powermatic now that has a dovetail. A couple of things I want to point out is you want a fairly tight shoulder in there that's clean. Generally you can cut that with a skew, or you can use a special dovetail tool, or in this case I've taken an old skew and repurposed it and ground it to with the bevel just on one side. And the idea is, once you cut this out the appropriate size, when you lay this flat, you can see it will actually cut that dovetail in there and make a nice clean dovetail. This dovetail doesn't have to be very deep to hold well, as long as you have good solid wood and that it's not punky. And you want to have at least 3/4 inch wood here, so you won't have any blowout. And again, if you can crush these fibers, and you can actually split these. If you don't have your dovetail cut to closely match your jaws, the dovetails can actually cut through here and blow it out. I prefer a tenon myself, because I just think it's faster and easier and safer. And in any case, you're going to deal with the bottom of the bowl, and we'll talk about that a little bit later. The one time I do use this is when we do a platter. Generally speaking, with a platter, you don't have a lot of wood, so it's very common to cut that recess, and it holds it very well. That's not a very deep recess, and with some experience you'll find it doesn't take much more than about 1/8 of an inch deep recess to hold this very, very securely when you're doing the front of the platter. This is a roughed out one, ready to be finished. Another item I want to mention, it's handy if you have lots of different sets of jaws, as we've got here. Sometimes it helps to come up with a little jig, kind of a no-go, no-go jigs for your different set of jaws, so it can show you what is the minimum size for the spigot or tenon, what's the maximum size for that jaw for a tenon, what's the minimum recess for that set of jaws, what's the maximum set of maximum set of expansion. You might then also put any special notes, like this power grip jaw requires a 15-degree dovetail. The maximum tenon size I have written down. The maximum speed when using this in this mode is 684 RPMs according to the manufacturer. So these can be handy when you do use lots of different sets of jaws. It's nice when you have small jaws to do small work, such as these pin jaws. But what if you don't? You're only going to do one item. Well, one thing you can use is actually use just the jaw slides themselves, as on this Supernova 2. You take the jaws off and you actually use these slides to clasp, and they will clasp either a square or a circle. And here's an example of a very simple finial that I turned, actually grasping it just with these jaws. It's not recommended for something too long, and it will only hold something fairly small, but it is something to consider as an alternative if you're in a pinch. Okay, we talked about screw chucks earlier, and we postponed the discussion of what they call a Woodworm screw, which is basically a screw chuck. And that's a large, specially turned screw with very, very deep threads on it, which holds very securely for pretty substantial work, and it is a very fast and easy way to mount a bowl blank. It's my preferred method, and most turners' preferred method of initially fastening a platter blank. So let's see how that works. You saw that little slot that the jaws will close in on. Before you tighten it, you can see there's some play on this. Pull it forward before you tighten it. That's not always intuitively obvious to the casual observer, and I threw my first couple of bowls thinking that it was supposed to be pushed back, but obviously as it gets tighter and tighter, the forces are going to pull this forward. So go ahead and pull it forward and tighten it. What I also find helpful on these, especially if you're turning green wood, is to have a little piece of paraffin around. Put a little bit of wax on that screw. It makes it going on easier, and it also makes it coming off on green wood easier. But here's an example of a platter blank that we'll use. Before we do that, let me show you another feature. For example, on platters, this is 3/4 inch stock. So you can't make the hole very deep or you're going to have a problem. And maybe that's cutting it a little too close. So the way you handle that is just make you a little spacer, 1/4 inch stock. That little bit of thread of no more than a 1/2 inch protruding is plenty strong for most platters until you get something of some substantial size. So this will spin on easily. And it also provides the benefit, I don't know if you can see the back here, it provides the benefit of giving you a larger surface to anchor this on. And there's one thing about this, the more you turn it, the tighter it gets, because the screw is tightening up as it goes clockwise, and with this coming to you, it gets tighter and tighter. So it can be sometimes an effort to get loose. But that works very, very well for bowl blanks as well as platter blanks. Another feature that can be very handy, maybe when you don't need the spacer to take up some space, and you're using it against a bowl blank, and maybe the face of the bowl blank is a little bit irregular because of the bandsaw or chainsaw work. If you'll make you a big washer like this, that when it's seated flat against the bottom of the jaw face, and it's even with the front of the jaw face, you have a much larger area to register on that bowl blank, giving you a much more secure hold. Pretend this is a bowl blank, but you can see you're just going to have a much, much larger area. And that larger area just makes this a lot stronger hold. And I wouldn't hesitate to initially turn a very large bowl blank using this. Well, it's bottoming out without having that washer, so we needed a bowl blank with a deeper hole. And that's it for the Woodworm screw. So in summary on chucks, generally, I would say if you're a novice or an occasional hobbyist user and budget very important, the lesser value price chucks such as Barracuda, Wood River, Pinnacle, or Apprentice are fine. If you know you're going to be turning, you enjoy it, and you're going to be doing it a long time, go ahead and get a good quality chuck system such as something made by One Way, Technitool, or Vicmark. They all have their individual peculiarities, but everybody that has one or the other seems to be happy with it, so they're all good. And the general rule of thumb again is bigger work, bigger chuck and bigger jaws, smaller work, smaller jaws, smaller chucks. Okay, we've talked about chucking between centers, we've talked about chucking without the need of tailstock support. Now we're going to move into friction chucking, which is generally going to be turning between centers with specialty chucks. Here's an example of one. It's a project on the front page of the August 2011 American Wood Turner. A Japanese toy called a kendama, which I got fascinated with, and I decided to make one of these for my son who likes to play with such things. One of the aspects of that requires you to make these special friction chucks to make this device, because this is concave to fit a sphere. They have to be perfectly sized. Then you have to turn the middle. So once you do these and you're getting ready to turn the middle, you're going to do it by turning between centers, between friction chucks, which I've got one that I made to go on the scroll chuck, another one that just simply slides over and holds well enough for the live center to do the job, to work just fine. So that's one example of a friction chuck. Now I want to show you another example of a friction chuck. A real common example is turning between friction chucks for turning a sphere. In this case, we're going to remove the scroll jaw chuck, and we're going to use, we'll talk about making these Morse taper fitting. I've got it padded with a little bit of closed cell fun foam from Michaels. Simply goes in there. This one, we talked about fittings for this 3/4. Here's another way to make one of those fittings where you actually take a bolt or a nut, 3/4 by 10-inch thread, glue it in and true it up. Thread this on. And then you're going to turn this. I'm not going to teach you how to turn a sphere, but when you get to this point, to turn away the tenons that stick out, you're going to turn it between a set of friction chucks like this. Okay, let's talk briefly about how do we finish the bottom of a bowl, some of the different checking mechanisms. Several of them are going to have to illustrate with slides. We showed you the cold jaws, and we've got a better picture of the cold jaws here. We also have something similar to cold jaws but easier to work with in operation. That's Longworth jaws, and we've got those on a couple of pictures as shown here. Another alternative is to make a large donut chuck similar to this one, except this is a miniature that's a special purpose one to use for coffee scoops, but the concept is the same in that a bowl would be mounted between the back plate and the front plate with the bottom protruding through the opening, and then you could finish off the bottom of the bowl through the donut chuck, and we've got a better picture of a donut chuck here. Here's another alternative, is putting it in compression, bringing up the tailstock support, putting it against this large flat Baltic birch plate with some fun foam on it, secure it, and then you're going to turn this down to a very small nib, a very small tenon, and gradually make it smaller and smaller until you are ready to pass it off, and you're going to do all the work on the lathe with the tailstock support until you get that nib, and that including finishing all the bottom, taking away this tenon and making it very small, and then you're going to take it off the lathe and knock that little nib off with a tool handle or cut it off with a chisel. And I'm going to show you one other approach. And that's using this as a jam chuck against the chuck. Some people just simply take a piece of a rag or in this case a piece of a mouse pad and put it against the chuck. I prefer to, in many instances, take a piece of scrap wood and with a tenon on it and cut the face to fit the bottom of the bowl. In this case, this is for my power grip jaw, so I'm not going to mount it here. So I'm going to use that other approach, use that mouse pad, and just use it like this, and bring it up. And it's similar to putting it against that large plate we had. And it accomplishes the same thing, and then you're going to turn it off the same way by reducing the tenon to just a very small nub that you can knock off with a handle or cut it off with chisel. Okay, let's talk about another way of securing wood by using mandrels. One of the most common mandrels that wood turners are familiar with are the mandrels such as this for turning pins. Morse taper on one end, and then you bring up the tailstock support, maybe with a 60-degree cone so it doesn't damage the point on your live center. Or you use this little specialty called a mandrel saver, which is a specialty live center that works real well from Penn State, that actually captures the end of this without any real pressure, and it keeps you from that tendency to crank it down too tight and bow it. So that's one type of commercial mandrel. Now let me show you some shop-made mandrels. We're going to start with one that's basically we turn our own Morse taper. Turn it between centers, and you can make you a little jig to make that a little easier. And you simply get a Morse taper, use that as a sample to make your jig, and then you can use that to check your work as you're turning this taper. And with a little practice, these become very, very fast. But an example of how you would use this is, or what you might use it for. Here's an example used for whistles. And it holds it on there without any need for additional support. Another type of mandrel is one held in a chuck. In this case, this mandrel, a mandrel like this can be used for, in some instances, some people that make birdhouse ornaments use these mandrels, making little tulip flowers, where you drill the hole to match the mandrel, in this case I think 3/4 of an inch, and it fits fairly tight, and if it winds up being a little loose, you just put a little piece of tape around it. And that secures it well for doing the final finishing. Normally mandrels are not used for rough turning. They're only used for finishing work, for the last final cuts on the end and sanding. And one more sample of a mandrel, a simple one. If you make pin cases, or rather needle cases, such as this, when you turn it, this is basically a lidded box. When you turn the lid of the box, you can use the body of the needle case to hold it, to finish it off. But when you're finished this and you part it off and you want to finish the end of the bottom of the needle case, then you just make a little mandrel and slip it on, and then you can do your last final cuts and do final sanding on that mandrel. Okay, now we're getting to the part of the demonstration I'll call the cool tool section. We're going to talk about vacuum chucking. And vacuum chucking, it really is a cool tool. It's primarily for finishing bowl bottoms. It's not for rough turning, and it's an alternative to those methods we've talked about before. The hassling with the cold jaws, the expense of $130 plus for a set of Longworth jaws if you don't make them yourself, and some of the other donut chucks, which take some effort to make. It's a very fun project, and it works real well. Let me show you the system that I made, and it's pretty typical. You've got several different components of a vacuum chuck. Basically, you have a vacuum pump, in this case a Gast 523 that I bought used off of eBay for about $90. You have the control mechanism or a manifold, which consists of a bleeder valve that reduces the pressure. When you turn on the bleeder valve, it brings in air in here, so I have a little air filter that filters any dust in your shop to keep it from going through your pump. and that's just a little Walmart automobile gasoline filter. Then you've got the pump here that will, the gauge that tells you how much pressure you're getting. I'm not going to get into all the details of inches of mercury or pounds of pressure, but I can tell you what we're looking at is when this needle spins up somewhere in here. If you get it too strong on thin stuff, you can actually break it. And then you've got the plumbing connecting all of this. This is a very inexpensive half-inch inside diameter hose from Lowe's. The motor didn't come with a switch, so rather than install a switch, I used an old power block from my Commodore VIC-20 days. The other component that's you can make or you can buy. I made one, wasn't happy with the performance, and chose to buy one from the source that we're going to show you on the slide. Made from this aircraft aluminum. It has 2 bearings in it, so similar to the finer live centers, it's got a lot of support in there. And then it slides in the Powermatic. It slides easily and seals with these 2 O-rings. So I'll show you how that slides in. It just slides in the hand wheel. You just spin the hand wheel and slide it right on. And now the next component are the actual chucks, and you wind up making these things. They're not expensive. If you use a Beal tap, as we showed before, you can tap your own. This is Baltic birch with it Michael's closed-in fun foam. This particular chuck works well for larger bowls or platters that have a flat surface that have been finish turned. You just screw it on and match your work up against it. I'm going to set that aside and show you some of the others. Here's one that's been tapped cherry with some MDF on the front and back with just a piece of Schedule 40 PVC. The edge has been rounded over with some that same closed cell micro fun foam from Michael's, about $1 a sheet, real inexpensive stuff. And this is the one we're going to use to demonstrate. And then here's a smaller one. This fits in smaller bowls. I generally go with the largest one that will fit inside a bowl, so if I got larger bowls, I tend to use the larger one. Alright, we're going to bear with me. I'm going to take just a moment to turn this pump on. I'm going to mount the bowl. I'm not going to waste time centering it perfectly. That's some technique you're going to have to learn. I just want to illustrate how fancy this thing is and what it can do for you. And I'm going to have to walk around the lathe and adjust the control once we get it turned on. Sweet gum bowl blank. I'm not going to get the kind of suction I want on this to do finish turning. We got to find a better example, I think. Okay, we're going to install this small chuck on here for this small bowl. This system has been moved from my shop, and I have it on French cleats on the wall where I can just reach over here and grasp all the controls. In this case, I'm going to have to kind of lean over or walk around the lathe to adjust the bleeder valve. how we're going to get a little bit of wobble on this, and that's part of the technique of screwing it up. I'm getting some leakage on this particular bowl. It takes some futzing around to figure out where that leakage is coming from. But that's basically it, and it holds it. You'd want to use tailstock support as long as possible while you're removing your tenon. Then move the tailstock away and go ahead and part off and sand that final part. There's several factors that, let me turn this off for just a moment, keep it running. Several factors that impact the strength of the hold as shown on the slide. These include the system leaks, your pump strength. Do you have one that does 4.5 cubic feet per minute? Or do you have a little Harbor Freight one that does half that might be kind of marginal? Wood porosity. How porous is that wood? What type of wood is it? Is it very dense? How wet it is. If it's wet, it'll seal better than if it's dry. How dense is it? How strong is it? What's the diameter of the piece being held, and how large an area that you have over that hole? Obviously that hole is the same size for every chuck, but if you have a bowl, the larger the bowl, the larger surface area and the more hold power you're going to get. Let me just kind of give you a sample of that. Here's an example of a rotary adapter that's shop made out of wood. It's got a bearing that I picked up at Lowe's. Lowe's doesn't sell them anymore, but you can get them at auto parts store. And it's not really glued in, it's just fastened with these screws. You can get these things, like I say, already made from JT Toolworks. I think it's on the slide. Another place you might want to look at some of these, getting some of these parts easily is Joe Woodworker, a site that deals primarily with veneer vacuum bagging, but they have a section on vacuum chucks. They have a good price on a manifold with the pump and the bleeder valve parts. Yeah. Thanks for watching. I hope you got something useful out of it. I would encourage you, if you're not a member of AAW, join. A lot of information on all the things I talked about and some of the back issues of their magazine. Thanks again.